prism. So like this, we will started with a small idea with a minimum deviation one. Next, we'll go for the maximum deviation one. Okay, now kids will go for, after learning the minimum deviation, we'll go for the maximum deviation. Already we have brought the expression for deviation, and this was the particular curve, the deviation as a angle of incidence. We just discussed the minimum deviation. So what is this deviation? So let me just once again brush up. Here the ray after undergoing. Okay, this is the emergent ray, this is the refracted ray, this is the incident ray, angle of prism. So the deviation, what we were discussing is this is what the deviation with the red color I will show it. Fine, at least now you are able to understand, and this is what that angle of incidence. R1, R2. This is the emergent angle. E I'll write it, or I2. This is a deviation. Okay, got this? Now we had the discussion on the minimum deviation. Now we'll focus on this maximum deviation. We know the basic deviation formula. This is our formula I1 plus I2 minus A. The deviation in fact will be maximum when I1 equal to pi by 2, because the deviation when I1 equal to pi by 2, the deviation will be maximum because the deviation depends on I1 and I2. When I1 equal, what is the maximum possible value of I1 is equal to pi by 2. The maximum possible value of I1 will be 90 degrees. Then the deviation will be maximum. So here we'll first put like deviation will be maximum when I1 is equal to pi by 2. So therefore the maximum deviation will be pi by 2 plus this E, I'll write it. And I2 is called as E minus A. What is E that we have to calculate? So how do we show this? So it will be grazing incidence some angle. Okay, just follow the diagram. It'll be much easier. So this is what I wanna, and this angle is what E. This R1. Okay, fine. This is grazing incidence. So what is the condition? It's grazing incidence. Now you can ask questions, so like, okay, this angle is 90 degree and there's a normal. Why do the ray will undergo, why the bending will occur here only? Why can't it just trace out, why can't it just graze this refracting phase? Why it will bend here? See, the idea is here on paper 90 degree, it will be maybe 89.99 degrees. The ray will be here. Will undergo refraction at the point where it is incident on a face. On paper, 99.99 what you write equal to 90 degree. If it is really 90 degree, the ray will just graze the refracting face this one. Why do it will bend here? So practically what will happen, this will not be 90 degree, it will be 99.99 degrees if the ray will undergo refraction. Again here it will undergo refraction here. And this angle is called as the emergent angle. This is what we should calculate because I know I1 is pi by 2. This E has to be calculated. Now come for the TIR. For if the incident ray grazes the grazes the boundary, then the angle of refraction should be equal to critical angle. So this R1 will become now critical angle. Then this will become A minus C. So we are not understanding. So we know R1 plus R2 equal to A. No? I'll write all these things here. What happened with Prism? Big headache. I will redraw it. Okay, this so R1 plus R2 is equal to A. Look at the diagram. Looking at the diagram, R1 plus R2 is equal to A. Then uh, I'll do one thing. I will write all these things nearby. Later on I'll bring it. So what is R1? R1 equal to critical angle. So what is R2? So we'll write it. R2 equal to A minus R1. And we know R1 equal to critical angle. So this will become A minus C. So now we will write the Snell's law equation using Snell's law. Mu uh, now using Snell's law, it will be mu sine of A minus C. Here. Mu of sine of A minus C should be equal to sine E, because what is the other medium? The medium on either side of prism, it is air. Can we replace E now? So this will be what is sine C? Sine C should be equal to 1 by mu, because the medium on either side of prism is like a rarer medium equal to air. So refractiveness of air will be 1. So sine C will write it as this E is equal to sine inverse of mu sine A. So substituting this in expression for delta max, so the maximum deviation, I got the formula pi by 2 plus this one minus E. This is that expression for maximum deviation. When do that will occur? At pi by 2. When angle of incidence is equal to 90 degree, then the deviation suffered by the ray will be maximum, and how much that maximum deviation depends on this quantity. So we have just brought an expression here. So when the deviation will be maximum means when angle of incidence equal to 90 degrees, what we, we are giving here. Okay, fine. So there's one thing. So now definitely you can ask, sir, what about this angle? Means now as 90 degree, when angle of incidence is almost 90 degree, the deviation will be maximum. So sir, can you show that deviation, maximum deviation? You are supposed to show that. Okay, we'll do one thing. I'll extend this line. This is the deviation, maximum deviation. I'll take it off this. The ray was the incident on the first phase at a grazing incidence, undergo refraction, and will emerge out. So this is the now this particular deviation, what we'll call this a maximum deviation. How much it is, it depends on these things. The below formula is there. Yeah. Then at what should be the angle of incidence? 90 degree. I want this particular angle. From principle of reversibility of light, if the ray of light is incident on this phase, then it will retrace path, no? Then also the deviation will be maximum. Then this will become angle of incidence. This will become angle of emergence. So, sir, we are not understanding. From principle of reversibility of light, if the incident ray first strike this phase at an angle of incidence E, then it will retrace path, no? So I'll draw the diagram better. Everything I'll show in one specific frame. If the incident ray so after refraction, I should not show parallelities. Then it grazes like this. No, this will become angle of incidence, no? Let it be as it is the symbol. So this will be 90 degrees. Critical angle, A minus C, this angle. I'll give the, this is the incident ray. Now look at the ray now. So what is that angle? Other angle should be E. That's all. And what is that E? We have brought this expression. Okay, are you getting now? There are two angles are there now. One angle where if it is equal to E, if the angle of incidence equal to E, the deviation will be maximum, and the other angle will be at 90 degrees. So, sir, like we are getting confusion. So, just shall I put one simple thing? For grazing incidence, grazing emergence, the deviation will be maximum. I want 90 degrees. This is critical angle A minus C. This is emergent angle, and the deviation is maximum. Okay, fine. Okay, I'll show this arrow like this. Now, what about the if angle of incidence equal to emergent angle? This will be very, very important, the discussion. You see now, this is the some emergent angle, and there'll be grazing emergence. There's actually the beauty of this particular topic. The angle of incidence is E. This is critical angle. Here A minus C. This is A. This is 90 degree. The deviation will be maximum here. So can you show that deviation? Where you show that deviation? You can see this is the deviation. Huh? Here this is a deviation. So for grazing incidence, and here grazing emergence, the deviation will be maximum. For grazing incidence, deviation is maximum. For grazing emergence, okay, hope everyone is able to understand. These conditions are very important. So that particular graph was here. I'll bring that graph also for you. And how much value of that also we know it. This is the E. Okay, and the curve is not symmetrical. This angle is not equal to, you can see this part of the curve. These two are not symmetric. If you measure this angle, delta theta 1, delta theta 2, greater than delta theta 1. Okay, the curve should not be symmetrical. So you should not show these two parts as symmetric. So there's a basic idea of the maximum deviation concept. Minimum deviation, maximum deviation. It's having its own applications. This one, maximum deviation also. Next again, a condition for no emergence. One more last statistical topic. We'll discuss this.